How's everybody doing today? So welcome to the All This Math IG Live. Today, wanted to do some long division. All right. Shout out to my youngin' Kwame. Asada wrote his name up here. It's my 10-month, almost 11-month-old son, Kwame. Asada wrote his name up there. Y'all saw Asada yesterday, on yesterday's video. I also want to shout out my nephew Zaire, who turns 5 today. All right. Shout out to Zaire, who turned 5 today. All right. Excuse me. Now, we're going to do some long division. We're not going to follow what's called the standard division algorithm. Not at first. I'm gonna do this example that way second. Initially, what I'm going to do is this other method. I think it's kind of cool. It's called division by scaffolding. All right. And it's set up the same way as a traditional, typical long division problem is, but it's a little bit different, and it might be easier for you. So what I do is, this is my dividend, the first number, and this is my divisor, the second number. So the divisor is still going to be written like outside of the long division symbol, and the dividend is still going to be written inside of the long division symbol. So we got, let me do this, got 5, and then 6,941. All right. Now, as I said, we're not following the standard long division algorithm at first. We're going to do that second. The first thing you want to do with the scaffolding method is it deals with place value. So you want to basically like look at your dividend and kind of unbundle it or break it up in terms of place value. So ask yourself, if this is 6,941, you say, well, how many thousands do I have? I have 6 of them. I have 6,000s. How many hundreds do I have? I have 9 hundreds. How many tens do I have? I have 4. How many ones do I have? I have 1. All right. So we're going to take this divisor, which is 5, and we're going to ask ourselves, how many 5s go into each of these place values? So into 6,000. So I think about 6,000. I say, well, how many 5s go into 6,000? Now, if I know that 610s go into 6,000, right? Because 600 times 10 is 6,000. All I need to do is attach that extra 0. 5 is half of 10. So that means if 600 times 10 makes 6,000, then if I take half of the 10 and get 5, then I have to double the other number to maintain the same product. So that means that 1,200, right? Or should I say 120, right? 120 5s. Well, actually, what I'm saying is like 1,200 times 5 is going to be 6,000, right? Because the question is, how many hundreds? 5, how many hundred times goes into 6,000, right? And it's going to be 1,200. So 5 times 1,200. So what do I do with that 1,200? And again, we're not following the standard division algorithm. We're doing something called scaffolding. So we write that number above the bar. So 1,200. Now again, where did this 1,200 come from? This 1,200 came from the fact that 5 times 1,200 is equal to 6,000. Because we're worried about place value. So first we're worried about the 6,000. 5 times 1,200 is 6,000. All right? So then what do I do with that? So I'm still going to multiply. So that's a little bit similar to the standard division algorithm. Now my second step is to multiply. So 5 times 1,200 we already said was 6,000. So what I do is I write the 6,000 underneath of here. Write my subtraction sign. Then I do the subtraction. 6,941 minus 6,000. And that leaves me with 941. Now, this is my new number, 941. So now I'm saying, okay, I'm looking at place value again. I got 941. Now I'm worried about 900 though. How many 5s go into 900 is the question. So I think about that, and I realize that 180. Because I know that 18 times 5 is 90. And if 18 times 5 is 90, and I'm worried about 900, which is just one additional 0 attached on at the end, if 18 times 5 is 90, then you attach an extra 0 to 18, you make it 180. So 180 times 5 would be 900. So I'm going to write 180. Now, what do I write the 180 though? because it looks like this 1200 took up all the space above the bar. We write vertically. So we're going to write 180 above the 1200. So we have our 1200, which was how many fives going to 6,000, right? And then we have 180, which is how many fives going to 900. And 5 times 180 is 900. So I write 900 underneath of 941. And I do my subtraction. And then I have 941 minus 900. The difference between those is 41. So then the next question is, how many fives going to 41? So the maximum amount of fives going to 41 would be 8. Because we know from our multiplication facts that 5 times 8 is 40. So then what do I do with that 8? I'm going to write that 8 above here. Right? And then I do 5 times 8, which gives me 40. And then I do subtraction. My difference is 1. And then with this method, I'm not worried about decimals, right? I deal with remainders. So I have a 1. 5 is bigger than 1, right? And once we get to a number down here that is less than the divisor, then we know that we're finished. And we know that we're dealing with a remainder, all right? So now, how do we get the actual quotient, though? You get the quotient by taking the sum of these three numbers. So therefore, our answer should be 1200 plus 180, that's 1380. 1380 plus 8 is 1,388. So 1,388, and 1 is my remainder. Right? 1,388, remainder 1. All right? So now, let me just try this using the standard division algorithm, right? Because that's what a lot of us are probably more comfortable with. That's probably what we remember from 3rd grade or 4th grade or whenever it was taught to us many years ago, right? But I do think that it's important for us to have different methods and different skills and different means and ways to approach certain problems and come up with certain solutions, all right? Because we don't want to be tied in and locked into just one method all the time. Now, let's do this again. Let's set it up. 6,941 divided by 5. 5 is still your divisor. 6,941, all right, is your dividend. So the typical way, we look at this one digit at a time. So 5 into 6. And essentially, the standard division algorithm is really the same thing that we did right here. It's just written up differently, right? And we might not think about this in terms of place value, but really that's what we're doing. So we say, okay, well, how many times does 5 go into 6? 5 can go into 6. 5 goes into 6 one time. All right? How you doing, Asada?
Good.
Want to say hi?
Hi.
That's what's up. So 5 goes into 6 one time. So we write the 1 above the bar, right? Then we multiply. Now with the standard division algorithm, I'll tell my students to remember these 3 letters. DMS. DMS. Now DMS stands for divide, multiply, subtract. Divide, multiply, subtract. Right? In that order. And you keep following that pattern over and over again until you basically run out of numbers to divide with. So we have a 6 here, so we're going to divide 5 into 6. 5 goes into 6 one time. And then we multiply. But what do we multiply? The 5 and the 1. 5 times 1 is 5. And then you write the 5, or that product, underneath for the 6. And then you're going to draw a minus sign, and you're going to subtract. So 6 minus 5 gives us 1. All right? Now we're going to start the pattern over again. DMS. Divide, multiply, subtract. And that's also very important because when you get to Algebra 2 or pre-calculus, you're going to have to know how to do polynomial long division. And polynomial long division is based on this. You're following the same essentially the same steps, but you don't just forget about how to do long division just because you feel like, well, I'm not in elementary school anymore, right? When you get to the higher level algebra, you still will need to know how to do long division because mathematics, each subject builds on top of the previous subject, all right? So we really can't afford to forget anything. But if we do forget some stuff, which is natural, we just go back to our notes and we practice some problems and then it'll all come back to us. So now, we want to divide again. But what are we dividing? We're trying to divide 5 into this number. Now, 1 is too small. right? We need a number that's bigger than the divisor. So what are we going to do? We go to the next digit in the original dividend, and you bring it down. So this 9 comes down. Now we're not dividing into a 1. Now we're dividing into a 19. So we say, okay, how many times is 5 going to 19? 5 goes into 19 3 times. Because if you say 4 times, 5 times 4 gives you 20, and 20 is bigger than 19. So we want to say 3. 5 goes into 19 3 times with some leftovers. All right? So 5 goes into 19 3 times. So you write your 3 up here. 5 times 3 is 15. Remember, DMS. DMS. Divide, multiply, subtract. Now, multiply 5 times 3. You write the product down here. Then you write your subtraction sign. That's the S in DMS. Now we subtract. 19 minus 15 is 4. Okay? Now, we start the process, start the pattern over again. DMS. Now we want to divide. 5, we can't divide that into 4 because 4 is not at least as big as 5. So we need to make this number bigger. So bring the 4 down to here. Now we have 44. So now, how many 5s go into 44? So we know 5 times 10 is 50. That's too much. That's too many 5s. 5 times 9 is 45. That's still too much. That's bigger than 45. What about 5 times 8 though? 5 times 8 will give me 40. So I'm going to write the 8 up here. And remember, DMS. You divide, you get 8. Then you multiply. 5 times 8 gives you 40. You write the 40 down here. And then the last part is the S, which stands for subtract. You're going to subtract as your last step. So then you have 44 minus 40, which gives you 4, right? And then we start the process over again. Back to DMS. Can 5 divide into 4? No, we already dealt with that the last go round because 4 is not large enough. So we want to make this number bigger. So all we do is we carry this 1 from the dividend down here. And now that 4 turned into a 41. So now we say, okay, well, how many times is 5 going to 41? 5 goes into 41 8 times because 5 times 8 is 40. So I write my 8 above the bar, right? 5 times 8 again, I multiply, you get 40. And we subtract. Now, we're not dealing with decimals. We're not going to add zeros on at the end. Perhaps we'll do that in another video because we should know how to do that. But we're not going to do that in this particular video. All right? We're just going to say that there's a remainder of 1. So we say 6,941 divided by 5 equals 1,388 with a remainder of 1. All right? So that's really all I wanted to get into today. Just a little bit of long division, just to switch things up, because long division is an important skill, and it's something that is foundational and fundamental, and it's good to master, and it also requires that we understand and know our multiplication facts, as well as many of our division facts, but we can't just forget about it once we get out of elementary school, right? Because we're going to have to use this skill again when we get to polynomial long division, when we get to graphing higher order polynomial equations and polynomial functions, when we're going to have to use like polynomial long division, synthetic division, all that type of stuff. We're going to have to use this, all right? So we can't forget about it, right? Follow me on Instagram at All This Math. Well, if you watch this video, you probably already do, but tell a friend to tell a friend. We're doing these videos every day, Monday through Friday. For now, we're doing them at around 6 p.m. Please, if you have particular specific math questions, please do not hesitate. Take a picture of your problems, send a DM to All This Math, and your problem might end up on this board. Peace.